We'll start by taking the information in the question and drawing a diagram. I have a ladder which is resting on rough ground, so I'm going to have a reaction force and friction, and at this point I'm told that mu is 1/5. So I can write out my first equation: friction equals mu r. It's a uniform ladder, so we're going to have weight 25G acting down. The point where it touches the wall, we're going to have a reaction. I'm going to use X, and it's a rough wall, so we're going to have a frictional force, which I'm going to call Y. And here mu equals 1/3. Friction equals mu r, in this case will be Y equals 1/3 X. Finally, I'm told that I need to apply a horizontal force at the base to prevent it from slipping. I'm going to call that force T. If I consider my vertical forces, then Y plus R has to equal 25G. And if I consider my horizontal forces, T plus friction has to equal X. Next stage of the question is to take moments, and I'm going to take them about the base of the ladder. The first force I meet is the 25G. It's halfway up the ladder, so that's L/2. The side that I have to add is the side that is adjacent to the angle, so my moment is going to be 25G times L/2 cosine 61, and that is going to be an anti-clockwise moment. Next force that I meet is the X. I have to add in the opposite the angle, and I've gone a distance L up the ladder. So this moment is going to be X times L sine 61, and it's going to be a clockwise force. Finally, I have the Y force. I have to add the angle beside the angle, and we've gone L up the ladder again. So this moment is going to be Y times L cosine 61, and that is going to be also a clockwise moment. Combining those three equations gives me 25G times L/2 cosine 61 has to equal XL sine 61 plus YL cos 61. And the first thing I can do is L appears in every term, so I can delete the L's. If I go back to the original equations, Y is 1/3 X, so I'm going to replace Y and evaluate 25G times a half cos 61, which gives us 59.389 has to equal X sine 61 plus 1/3 of X cos 61. Easiest way to deal with the right hand side now is to factorise and then divide the 59.389 by the factor, and this gives us 57.313, 57.3 newtons to 3 significant figures. Now we must combine all of the equations to work out the value of T. So to work out T, I need to know friction in X, and I know X. So I have to work on working out friction. Y is 1/3 X, so that's 1/3 times 57.313, and that gives us, once I know Y, I can work out R, because Y plus R is 25G. So R will be 25G minus Y, which was 19.104, and that gives us 225.895. I now can work out friction because it is 1/5 of R. so it will be 45.179. And finally I can say that T plus friction has to equal X. So my X will be the 57.313 minus the 45.179, and that gives me 12.13, 12.1 newtons to 3 significant figures.